So this is question number 5. Decompose the parallelogram into a rectangle. Use the rectangle to find the area of the parallelogram. First off, it said in the question, decompose. Decompose means to break apart the parallelogram into a rectangle. So that means we need to take apart this parallelogram at the height, move it over to this side over here, and make a rectangle. Yes, it may be shifted, but we're making a rectangle. We shouldn't have any questions. This is a square, so you should eliminate this one. This is also a square. 7 by 7 is a square. The sides are equal. The only possible answer choice is C. And then we made the shape of a rectangle. So let's pick this one. So C is the only possible answer. And then since we made a rectangle, the formula for a rectangle is area equals length times width, or base times height. And the base and the height is 19 by 7. So we have to multiply 19 times 7 to get the area of this figure. 63. Which is 133, and then we have yards times yards, which is yards squared. No one should have questions. A parallelogram is just a rectangle that's been slightly shifted. So let's look at this a little more of the reasoning behind that. So,
to decompose a shape, break it up to form other shapes. You can decompose a parallelogram to form a rectangle. Suppose you have a parallelogram with base B and height H. To decompose the parallelogram into a rectangle, cut the parallelogram along its height. Move the triangle to the other side. Then push the pieces together to form a rectangle. So you can decompose a parallelogram to form a rectangle with the same base and height as the parallelogram.
So that's why we use the formula area equals base times height. So we're moving on to number 7, the error analysis of question. A teacher asked a student to find the area of a parallelogram. The student said that the area is 90 feet squared. What is the correct area? What error did the student make? So remember, a parallelogram is just a rectangle that's been shifted to one side. So if you decompose, well, you can decompose it anywhere. So we decomposed it right here. So we have the base and the height. Remember, the base and the height must form a 90-degree right angle. So that means that the two lengths are perpendicular to each other. So if we look here, our right angle is right here. So that means the bottom of the right angle is going to be the base, which is 5. So the base must be equivalent to 5. And then perpendicular to that 5 base is this height, which is 26. So we're going to write the height is equivalent to 26 feet. And we have feet. Now, since a parallelogram is a rectangle that's been shifted to the side, we're going to use the formula for a rectangle, area equals base times height, because they both take up the same amount of space. And then we're going to substitute. You always start with a formula. And then we want to substitute. So we don't know the area, so we leave the A. We bring down our equal sign. We know that the base is 5 feet. 5 feet. We know that the height times 26 feet is the height. And then we can multiply 26 times 5 to get the area of the parallelogram. So we have 6 times 5, which is 30. 5 times 2, 10 plus 3 is 13. So the area of this parallelogram is 130. And then we have feet times feet, which is equivalent to feet squared. And remember, area is always square because it's two-dimensional, length times width. So the area of this parallelogram is going to be 130 feet squared. So I'm going to put that into this right here. So 130 feet squared. And then it's an area analysis question, so we're going to get another part to this. So I have my area, part 1. So what error did the student make? So how did this student end up with 90? Well, we have to figure that out. So we know the answer is 130. So the student added the base and the height. They added the base and the height. So if we add the base and the height, the base is 5 and the height is 26. If we add the base and the height, will we get 90? We're going to pick A or eliminate it. I can see that this is not going to add up to 90. So I'm going to eliminate that one. Moving on to B. The student added the two side lengths. If you add the 2 side lengths, that's still not going to add up to 90. So I'm going to eliminate that one. The student multiplied the height and the wrong base. Okay, maybe. The student multiplied 2 side lengths. So how did they end up with 90? So if you multiply 18 times 5, 8 times 5 is 40. That is equivalent to 90. So this student used the wrong side length. So this is the base. They use 18 as the height, and 18 is not the height because that's not 18 is not perpendicular to that 90-degree right angle. 26 is. So the student actually multiplied the height and the wrong base. So this is the height 26 and the wrong base, or one of the dimensions of the base times height was incorrect. That 18 was incorrect. So I'm going to pick the correct answer. The student error was multiplying the wrong. The student multiplied 2 side lengths. Yeah, the 5 and the 18. So they didn't multiply the base. The student multiplied the height and the wrong base. So the base was the right, which was 5, but the height is 26. So the height is actually wrong. So these are backwards. So the correct answer is D. The student multiplied 2 side lengths. So we have this one and this one. That is incorrect. All right, moving on to the next question. Number 8. So find the for the geometry project. The students are cutting triangles like the one shown. All the measurements are in inches. Compose the triangle into a parallelogram. Then find the area of the triangle. So first off, it says compose the rectangle into a parallelogram. That right there tells me that B is the wrong answer because that is not a parallelogram. That looks like a rectangle. In fact, it is a rectangle. 26 by 30 is a rectangle. A and C looks more like parallelograms. But they both look like parallelograms, and it looks kind of confusing. Because we have 30 as the height and 27 as the base, and then we have a side length of 37. So if I look here, I need to come up with something that's going to differentiate between A and C. And this will be on your test. You do need to understand this. So if you look at it, if you make a copy of this and rotate it and compose it, it'll look something like this. 37 needs to be across from 37. If you look here, we have 37 right here and 37 right here. This 37 should actually be right here and not down here. So I'm going to eliminate this one. If you look at this one, 37 is matched up with 37. So that tells me the one that I need to pick. And now I need to find the area. So I'm going to use my formula for a triangle. First, I'm going to identify my base and my height. So I have to find that 90-degree right angle, which is right here. So that tells me my base is going to be equivalent to 27 units squared. And my height is going to be equivalent to 30 units squared. So I'm going to use the formula for a triangle. Formula substitute evaluate. Area equals 1/2 times the base times the height. So I'm looking for the area. I'm going to keep 1/2. I'm going to multiply by 30 since I can take half of 30, which is 15. And then I'm going to multiply that by 27. It doesn't matter which order you put this in. So half of 30 is 15 times 27 Once you do 15 times 27, you end up with 405 units squared, or square inches. Oh, it's inches squared. That's going to be the area. So 15 times 27. And then I'm going to put that into here, which is 405. And that is the answer to that one. So that's how you do this question, and this will be on your test. Moving on to number 9. Find the area of the triangle by composing it into a parallelogram. So, which one could you eliminate without even thinking about it? We can see that B is not a parallelogram. It says find the area of the triangle by composing. That means we need to make a copy and compose it, add 2. And we need to make a parallelogram. So we can eliminate B, right? And then we have to figure out, okay, is the answer going to be A or C? So we come down to A and C again. So if we look here, C is the correct answer. Because if we look here, we have a base of 16, and we have the base and the height must be perpendicular to each other, which means they intersect and form a 90-degree right angle. So since our 90-degree right angle is right here, the base must be equivalent to 16 meters, and the height is equivalent to 9, because that is where the two lengths meet up at that with that 90-degree right angle. So if you look here, we have a obtuse triangle. We make a copy and rotate it and form a perfect parallelogram, where we still have this 9 meters, which is perpendicular to the 16. Now, if we come over here to A, we should eliminate A. This doesn't even look like a parallelogram. Well, it kind of does if you turn your head sideways. But if you look here, this figure, this part right here is 16, and it must be connected to 16. Okay, that checks out. But what happened to this this perpendicular 90-degree right angle? And when you make a copy and rotate it, it should compose and form like this, not down here, right? Now, why does an obtuse triangle form a parallelogram? Here is the reason for that. So let's watch this.
Suppose you have an obtuse triangle with height h and base b. To compose a parallelogram, first, make a copy of the obtuse triangle. Rotate the copy, and then push the triangles together to form a parallelogram. So you can use an obtuse triangle to compose a parallelogram with the same base and height as the obtuse triangle.
And since we only want the area of half of the figure, that's where we get divided by 1/2, but we should be past that. So let's go back to the homework. So we know that C is the correct model. So we have triangle, we made a parallelogram. Now the formula for a triangle is area equals 1/2 times the base times the height. Why is that the formula? Because when we made a copy and we rotated and composed it, we formed a parallelogram. And if we decompose this parallelogram right here and move this piece here, we're going to get a perfect rectangle with a base of 16 and a height of 9. So this forms a rectangle. So we can build a formula with area equals base times height. But since we only want the area of this gray shaded region, which is half the area of the parallelogram, which is the same as the rectangle, we can divide by 2, and we know dividing by 2 is the same as multiplying by 1/2. So we can use either one of these formulas to find the area of this obtuse triangle. So I know what my base and my height is. They're perpendicular to each other using this right angle. So 16, I'm going to put half of 16 meters here for the base. And then for my height, I'm going to put in 9 meters. And then I have half of 16, which is 8 meters. And I'm multiplying by 9 meters. 8 times 9 is 72. Meters times meters is meters squared. So the area of this right triangle is 72 meters squared. Always start with your formula, substitute, and evaluate, and you can't go wrong. Moving on to the next question. So this is the similar type of question, actually the same, we just have different numbers. So we want to find the area of the obtuse triangle. How do I know this is an obtuse triangle? Because I have an angle right here that's greater than 90 degrees. So since that angle is greater than 90 degrees, my right angle is going to be off of the triangle. So I need to identify my base and my height. So my base is going to be equivalent to 32 meters. And it doesn't matter which one you use, as long as your base and your height are perpendicular to each other. So if this is my base, 32 meters, and perpendicular to that is this 12 meters, I have to use 12 meters as my height and not 17, because I have to see where that 90-degree right angle is. It's connected to this 32, and that is connected to this 12. So I need to use these dimensions right here to find the area of my obtuse triangle. Now, if I want to find the area, I can make a copy, rotate it, and compose it, and it'll look something like this to form a parallelogram. So I'm going to use the formula for a parallelogram, which is area equals base times height. But I only want the area of half of the triangle, half of the parallelogram. So I'm going to divide it by 2, which is the same as multiplying by 1/2. So I'm going to use the formula for a triangle. So I don't know what the area is. That's what I'm looking for. I'm going to substitute my base in, 32 meters times 12 meters times 1/2. Now, because of the commutative property of multiplication, it doesn't matter which order I put these, I multiply, because it's all multiplication. I'm still going to get the same product. So I'm going to do half of 12 first, which is 6 meters. And then I'm going to multiply that by 32 meters. And then I have to do 32 times 6, which is equivalent to 192. And meters times meters is meters to the second power. So the area of this obtuse triangle is 192 meters squared, or square meters. 192 square meters. And then I'm going to go to the next question. All right, so a flag is to have the shape of a triangle as shown. Okay, to find the area of the flag, first compose the triangle into a parallelogram. The material for the flag costs $6 per feet squared. So every square foot you're going to pay $6. How much will all the material cost for the flag? So you have to make sure you pay attention to this part right here, because you have to find the area and then you have to multiply it by 6, because each square foot costs $6. But first we have to figure out which figure this is. So it formed a parallelogram. I can already eliminate 2 of these answer choices because it doesn't look like, it's not a parallelogram. This is not a parallelogram. This is not a parallelogram. This is a parallelogram. So if I look here, I have a base of 14 and a height of 14 and 4/10 and a height of 5 and 8/10. And then if I make a copy and rotate it, this right here is 14 and 4/10, and this length right here is the same length as this length right here, because they're parallel to each other. So 7 and 2/10 is parallel to 7 and 2/10, and then the height is going to still be the same. So this B is actually what I'm looking for. This right here doesn't even make sense. That's not a parallelogram for one. And if you make a copy and rotate it, the equal lengths need to be parallel to each other or connected in some kind of way. So if this is 7 and 2/10, this needs to be 7 and 2/10. If this is 14, this needs to be 14 and 4/10. But as you see here, the 7 and 2/10 is right here. So this one is incorrect. This one is not even a parallelogram, it's a rectangle. So the only option here is B. And you will see plenty of these on your test. So let's pick B. And then it says the material for the flag will cost. First, we need to figure out how many square units we're going to need to fill this flag. So the first thing we want to use is our formula for a rectangle. Area equals 1/2 times the base times the height. Identify your base and your height is the two that's perpendicular to each other. So I have my base and I have my height. My base is going to be 14 and 4/10. My height is going to be 5 and 8/10. And these are both feet. So I'm going to substitute formula, substitute 1/2, keep that, times 14 4/10 feet times 5 8/10 feet. So I need to take half of 14 4/10, which is going to be 7 2/10 feet. And then I need to multiply that by 5 8/10 feet. So times 5 8/10 feet. And I'm going to get an area equivalent to 41 76 feet squared. That does not answer the question, because this doesn't say what is the area of the flag. It says the cost of the material. And right here it says the material of the flag costs $6 per foot. That means for each foot, we know what per means, for each or for every, right? For each or for every. So for every square foot that I have down here, I'm going to pay $6. So for one of those 41 76 feet, I'm going to pay $6. So easily you can find the answer. Repeat addition is multiplication. 41 76 times $6 per foot is going to be equivalent to $250.56. Now you can also use this as a conversion factor. $6 per 1 foot squared. So if I know that I need 41 7600 feet squared, and I want to convert that to dollars, you multiply by the conversion factor, which is this right here. I need feet squared in the denominator because I have feet squared in the numerator right here. So I'm going to put 1 foot squared here. And the conversion factor that I need to go with that is $6 in the numerator. Feet squared cancels out with feet squared, and I multiply across 41 times 7600 times $6. And that's going to give me the same exact answer. So you can use conversion factors, or you can just use common sense. For every square foot, you're going to pay $6. So for 1 square foot, you're going to pay $6. For 2 square feet, you're going to pay $12. For 3 square feet, you're going to pay $18. And that is repeat addition. 6 plus 6 plus 6 plus 6. Keep adding. And then that is repeat addition. You can easily get to your answer. So I'm going to put the answer in. So you have to make sure you read the question completely. $250.56. And that is how you answered that question. All right, let's move on to number 12, which we already have. You can, what is the area of the trapezoid? Ooh. Okay. So we want to make the trapezoid into a parallelogram. So the first thing we have to do is make a copy, rotate it, and compose it. So let's go back to the lesson where we learn how to do that. So here's an example of that.
Method 1. Compose the trapezoid into a parallelogram. First, make a copy of the trapezoid. Then, rotate the copy. Then push the trapezoids together to form a parallelogram. The parallelogram has the same height as the original trapezoid. And the base of the parallelogram is equal to the sum of the bases of the trapezoid. So the base of the parallelogram is 17 feet.
So you have 2 base when you're dealing with trapezoids.
The area of the original trapezoid equals half the area of the parallelogram. The formula for the area of a parallelogram is base times height. Substitute 17 for the base.
All right, so we're going to talk about that with respect to this question. So the first thing you want to do is make a copy and rotate it. So I have my trapezoid right here, and I have my dimensions. I want to make a copy. So I'm going to make a copy and rotate it to form a parallelogram. This 3 now becomes a part of the base. This 12 is up here, and the height is still this should look something like this. Okay. Parallelogram, yeah. So the height is going to be 4. So now I formed a parallelogram. The formula for a parallelogram is equivalent to base times height. But since I only want the area of half of the figure, if I drew it correctly, I only want the area of half, so I need to multiply by 1/2 or divide by 2. So now, instead of having one base, I don't have a length of 12 anymore. This is not my base anymore. I have extended my base by 3 units. So I have to do a base 1 and a base 2. So instead of just putting base, I'm going to put base 1 plus base 2. And I'm going to put that in parentheses. Where 12 is my B1 and 3 is my B2, base 2. And I'm going to multiply that by the height times 1/2 to find the area of just this red part right here. So I'm going to substitute 12 plus 3 times the height, which is 4, times 1/2. Parentheses goes first in the order of operations. 12 plus 3 is 15 times 4 times 1/2. I'm going to take half of 4 first, which is 2, times 15, which is 30 feet squared. This is so easy if you understand what's going on. So I'm going to put that answer into the formula, which is 30, and then I'm going to go to the next question. You will see plenty of these. All right, so decompose the regular hexagon into 6 matching. So whenever you have a shape that's not a rectangle or a rectangle or a square, you have to decompose it into familiar shapes. So this shape right here is a hexagon, which means it has 6 matching sides, a regular hexagon at that. So that means all of the edges have the exact same length. So if this is 6, this must be 6, and all of the edges have a length of 6. And I can decompose this into 6 matching triangles. So I'm going to decompose it like this. And now I'm going to have 6 matching triangles. So I'm going to find the area of one triangle. So the area of one triangle is going to be equivalent to 1/2 times the base times the height. And then since I have 1, 2, 3, 4, 5, 6 matching triangles, I can multiply by 6 to get the area of the figure. How much space is this hexagon taking up? So I can do 1/2 times 6 centimeters times 5 and 2/10 centimeters. That 0 is not significant. And then I need to multiply that by 6 to get how much space this figure is taking up. Half of 6 is 3 times 5 and 2/10 times 6. So I can do 6 times 3, which is 18, and then multiply that by 5 and 2/10 to get 93 and 6/10 centimeters squared, because area is 2-dimensional, is going to be squared. So you have to decompose it. So the area of one of the triangles is going to be equivalent to 3 times 5 and 2/10. So the area of one of the triangles is going to be 15 and 6/10 centimeters. So the area of this one triangle by itself is 15 and 6/10 centimeters squared. But I have another one with the same exact area because it's taking up the same exact space. And I have another one that's taking up the same exact space. Now you can add these, but we know repeat addition is the same as multiplication. So I can just take the area of one triangle and multiply by 6 of them to get my final answer. So that's all that I did there. So I'm going to substitute that answer in right here, which is 93 and 6/10. And there you go. Moving on to the next question. So a teacher tells the students to find the area of the shaded region. The class is to use the area of the triangle and the area of the square, and students incorrectly stated that the area is 672 centimeters squared. What is the correct area of the shaded region? So we only want the area of the shaded region. So this goes back to that part to whole understanding, part to whole. So we only want the area of this shaded region. So we know that this is a square. So the area of the polygon plus the area of the triangle is going to be equivalent to the area of the square. right? Because both of them together takes up the amount of space as the square. So the area of the square, I need to use area equals s squared, where the side length is 24 squared. So 24 centimeters squared is going to be 24 times 24, which is 576 centimeters squared. And then I can find the area of the triangle, which is this part, because I know the area of a triangle. I know the formula. Area for a triangle is equivalent to 1/2 times the base times the height. So I know the base of this figure is going to be 24 because it's parallel to this. So I'm going to have 1/2 times 24 times the height, which is right here, which is 8 centimeters, times 8. Half of 24 is 12 times 8 is going to give me the height of the triangle. So 12 times 8 is equivalent to 96. So the area of the triangle is equivalent to 96 centimeters squared. So if I know the area of the triangle is 96 centimeters squared, and I want to find the area of the shaded region, what could I do? Solve for my variable, get the unknown by subtracting the area of the triangle from the area of both of them together, and then I get the variable x on one side of equal sign, which is 576 minus 96, which is the area of the triangle, and I get 480 centimeters squared. Now what does this x represent? This x represent the area of the polygon, because that's the variable that I substituted in is in place of the area of the polygon. The area of the triangle is here. The area of the triangle and the polygon, the area of the square, both of them together is here. So I substituted and got the area of this polygon right here. So I'm going to put that area in, which is 96. Oops, that's not right. It's 480. 96 is actually the area of the triangle, but it's asking for the area of the shaded region, which is this region right here, which should be more than both of them. Well, it should be more than the triangle. Okay, so moving on to the second part. So they got the answer 672. What was the area of that? So maybe, let's see, if we do 480 plus 96, is that what they did? No, they did not. 480 plus 96. So we have to go through each one of these answer choices and pick or eliminate. So I'm going to do the first one. So they didn't do A because 480 plus the area of the triangle 96 is 576, which is not the same answer that the student got. So it's not A. We're going to eliminate A. So if we look at this question A, the student added the area of the triangle and the area of the square. So if we look at this, the area of the square, the area of the triangle is 96. And if we add that to 576, we end up with this 672. So that's exactly what the student did. So we cannot eliminate A. We actually have to pick A. And since our answer is larger, since the student error was greater than our answers 480, we know that they didn't subtract because that's what they were supposed to do. So we should automatically eliminate B and C. And then you should pick D or A because the answer that the student picked is larger than our answer, right? And let's move on to the last question. So the schoolyard has an area of 3,696 feet squared. The section that is in the shape of a triangle is used for picnic tables. What is the area of the section for the picnic tables? The area of the section of the picnic tables is. So we're looking for the area of the picnic tables. So what is represented by the picnic tables? The section of the shape of a triangle. So this right here. And this is more like a 7th grade problem, but you can do it. So if X is the length right here, so we have the area, the total area of both of them together is equivalent to 3,696 feet squared. Now, if you think about this, this length right here is x, and this length right here is a unit, but we don't know what x is, and you don't even need to know what x is. But you can figure it out. So if you look here, this is x, and this is x, and this down here is 2x. This right here must be the same as that, because x plus x is equivalent to 2x, right? So that's how we ended up with 2x down here, 2x. So we have x and we have x, right? So now we know, since these have the same base of x, the triangle and the rectangle, and the height of both of them is 44, we can say that this right here is half the area of this, right? So what we want to do is find out what the area is. So if the area of this, if they have the same base and the height, I can divide this right here, decompose this into 3 matching triangles with the same base and the same height, right? So that means if I have 3 right triangles, let's draw right triangles, 3 right triangles with the same exact area and the same exact height, the area should be equivalent to 3,696 feet squared. So if I have x plus x plus x, if I want to figure out the area of one triangle, I can divide it by 3. So if I say x plus x plus x, I want to find the area of one triangle. So the area of all 3 of them is this. And if I add these together, x plus x plus x, that's equivalent to 3x equals 3, right? And then I can divide by 3 to get the area of one of the triangles, which is what I'm looking for, the area of one of the triangles. So x is equivalent to 3,696 feet squared divided by 3, which is 1,232 feet squared. So since they had the same base and the same height, all of the triangles, I was able to divide the area of all of them together by 3 to find the area of the triangle, which is the area of the picnic. I mean the picnic area. 1, 2. Now there are other ways to do this.